Welcome to today's webinar with the title Basics of Printed Circuit Board Production. I am Andreas Schilp, your host of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speaker of today's webinar is Klaus Schilmulak from our Technical Project Management at Würth Elektronik Circuit Board Technology. Welcome, Klaus. And now I wish you lots of fun and new information.
So, hello, and also from my side, welcome to today's webinar. As Andreas already told, my name is Klaus Schilmulak. I've been working at Würth Elektronik since over 20 years now. And over the years, I've been mainly involved in technology or process development. For the last 4 years, I've been working in the technical project management, and we are looking on special customer requirements and their implementation in production. So what we will talk about today is a general overview about PCB technologies. We will look on some IPC standards. We look on the on copper foils and laminate. This means on base materials, and we will have a look on production for would say a 4 or 6 layer multi-layer with with core production technologies. So basic structure of a printed circuit board was and is an insulating carrier material with copper traces, of course, that ensure the connections between the components. These are many different types of printed circuit boards today. The main groups are rigid boards, which I would say the main group, which is the main group. We have flexible boards, and we have the combination of rigid and flexible, of course, which is called rigid flex boards. The substrate for rigid printed circuit boards is, for example, FR4, which is phenolic paper, or FR4, which is glass fiber epoxy fabric. It could be also ceramic or aramid or other materials. FR4 refers to a class of flame retardant composites and is the standard material in printed circuit board technology. For flexible printed circuit boards, you will find mainly polyamide, but it could be also polyurethane and other materials. But main material, of course, is polyamide. The IPC, which is the Association of Connected Electronic Industries, is a global association for the printed circuit board and electronic industry, providing all standards for all phases of the product life cycle. We will come in detail afterwards. Sorry for that. Sorry. The IPC describes manufacturing process of printed circuit boards in a multitude of guidelines, from design to material specification, acceptance criteria, and assembly. The issues of laminates, copper, and acceptance criteria are also discussed. We will look on the printed board acceptance and the laminate standards afterwards. The first one is the IPC A600, which defines acceptance criteria for the finished printed circuit board. Mainly externally visible features are considered. For example, class 1 is general electronic products, I would say low-cost products. Class 2 are special electronic products, and class 3 are products with high functional safety or reliability. The main difference between all these classes is the level of control. The classes define the permissible errors in the production of the panels. On the left side of the screen, you can see an example of acceptable classes for flatness. the IPC 610 family, which is divided in different standards for rigid boards, for flexible boards, for high frequency boards or HDI boards, have again various classes for printed circuit boards, and it defines and describes material properties and material values, and classifies them again into 3 defined classes for electronic products, as you can see on the right side. For example, you can see here the copper thickness or the external conductor thickness after plating. Furthermore, the IPC 610 describes technical requirements, and tests for verifications are described. In the IPC standards for laminate, you can find specification sheets which contain records on specific material systems. For example, reinforcement types are described, which could be glass or aramide. Resin types are described. For example, if it's epoxy or polyamide or something like this, or fillers and flame retardants, glass transition temperature, and even electrical properties are described. So now we would like to make a survey with you. It's a multiple choice survey. The question is, what is the most commonly used resin system for printed circuit boards? Is it epoxy, polyamide, PTFE, which is polytetrafluorethylene? Is it PPE, polyphenylene ether, or is it BT, bismyelite triazine harz resin? Sorry. Please make a choice.
Okay, so actually we are at 40% participation, so we will spend another few seconds for you to make your choice. Afterwards, I will close the poll and show the results. So now we have got nearly 70%, just a few seconds. Okay, last chance for you to make your choice. And now I close the poll and show the results. So as you can see, we have a favorite material, which is epoxy with, how much is it? 86%. Yeah, that's really much. So second place for polyimide, 10%, and 3% for PTFE. So that's the result from your choice. And now we'll hand over to Klaus. Maybe he can explain a little bit about the different resin systems. Thanks for your participation.
So, thank you. All these 5 resin systems are used in printed circuit board technologies, of course. Main resin system is epoxy, which is used for all rigid boards, of course, and even in rigid flex boards. Polyamide is used mainly in flex boards, of course, and in rigid flex boards. PTFE is for high frequency boards, same as it for PPE, which is also used in high speed, high frequency boards. And BT is, I would say, a very material which is used for high reliability or high temperature uses. But the main material, of course, is epoxy and then polyamide. So sorry, now okay, now it works. So now we will come to the laminate itself. This means copper, prepreg, and the core material, which are the 3 basic materials. Prepreg derives from previously impregnated. So prepreg is the dielectric material, of course, made by impregnating fiberglass fabrics with special formulated resin. The resin has specific material, electrical, thermal, and physical properties, which makes it would say the main material for electronics. Copper foil for printed circuit boards are generally used in two types. The first one is electrodeposit copper, which is in the IPC called ED copper, and rolled annealed copper, which is called RA copper in the IPC. The copper foils are formed in different ways and treated differently to improve and maintain adhesion to the prepregs and the electric materials. Copper clad materials or cores consist of an inner layer of prepregs laminated on both sides with a thin layer of copper foils. Lamination is achieved by pressing together one or more layers of copper and prepregs under intense heat, pressure, and vacuum. So first, let's go to the copper foils. The copper foil of the outermost layer is the conductive medium through which the electric current flows, of course. Copper traces on a PCB are made by selectively etching the copper foil. Traces make the electrical connections on the circuit boards. Next, we will look on the copper foils itself. The IPC describes more or less two copper types or classes. The first one is electrodeposit copper. This type of copper has a vertical grain structure and a rough surface. Electrolytically deposit copper is normally used for rigid PCBs. RA copper, which is called rolled annealed, it's thin rolled copper, and this type of copper has a horizontal grain structure and has a smoother surface, making it ideal for rigid, flexible, and flexible PCBs. The nominal foil thickness which is normally 18, 35, 70, or 105 micron, never corresponds to the foil thickness on the PCB or on the final product. Here, the copper foil thickness refers to the IPC 6010 family. Because we have a lot of, I would say, pre-cleaning processes and etching processes, which reduce the foil thickness of, for example, 18 to minimum 13 microns. The foil treatment, which is the last point, describes the roughness of the foil on the prepreg side. The IPC defines which means 5 profiles. In practice, however, manufacturers offers further foil profiles. The IPC, the lowest value of the IPC is to 5.1 micron. On the market, you can find profiles down to 1 micron at the moment. The FR4 base and composite material are the classic material for all technologies in the PCB industry. Prepreg is the adhesive standard and is the medium for all common PCB technologies. The prepreg itself is used to bond the individual rigid and flexible cores, this means inner layers and copper foils. The prepreg consists of a glass fabric pre-impregnated with resin and hardener. Now let's have a more detailed look on the prepreg itself. Standard materials commonly used at Würth Elektronik and in Europe are 5 glass types, which you can see on the right side. The thinnest one is the 106. The thickest one is the 7628. In Europe, we have, as described, we have 5 glass types. In Asia, you can find even more glass types. The glass type itself is described by the filament thickness and the number of fibers. And of course, you can find the number, I would say, the thickness of the resin. Low flow prepregs, which is also on the market, differs from normal prepreg in the formulation of resin and hardener and in the manufacturing process. Now we come to the cores. The cores are basically made of prepregs and copper foils, of course, that have been laminated and cured. There are a variety of materials with different thicknesses, epoxy properties, and glass fabric types. Typical copper thickness is 80 micron, 35, and 70 micron. Core thickness could be from 50 micron up to 100, 200, 400, and even more, of course. The TG values for standard FF4 materials are 135, 150, and 170 degree. These materials are, I would say, called standard at Würth Elektronik and even in Europe. The TG value is somewhat confusingly called the glass transition temperature. Of course, the resin is not converted into glass. Above the TG value, the epoxy resin structure becomes soft and elastic. Below the TG value, the resin hardens, and this is called classification. So now we will have a look on the production steps. We know, I would think, the basics of the materials. So now we start with production. The starting material, as described, is our FR4 cores, and these cores are laminated on both sides with copper. With this starting material, we go through a chemical treatment to clean the copper, which reduces the copper thickness, of course. And these boards are then laminated directly with a photosensitive film or resist. Then the exposure step is carried out using UV light, and the PCB data of the inner layer is transferred to the film. Next step is that the exposed plates run through a process sequence called develop, etch, and strip. First, the unexposed resist is developed or washed off. The remaining resist defines the PCB layout and protects the copper, so that all copper outside of the layout is removed in the subsequent etching process. In the final process, the resist is washed off and the PCB layout is visible with the copper structures. We will have here the first quality gate, which is called automatic optical inspection. All inner layers run through this quality gate and through inspection. After that we come to the multi-layer layup. The copper has been pre-treated again. It is, I would say, a micro roughening of the copper to get a better adhesion. The edge cores are laminated with prepreg and copper foils in the hot press process. This process takes place under vacuum, pressure, and temperatures up to approximately 200 degrees Celsius. The pressing receipt itself depends on the material and the TG of the material. After lamination, we have another quality gate, which is called X-ray or Röntgenbohren. Here we check the offset of the cores, of each cores to the other one, and the layer offset before drilling, of course. So after lamination and the X-ray, the edges are trimmed and the drill packages are assembled. This package consists of a drill pad, a PCB, and a cover layer. Next step is drilling the through holes with a common diameter of 0.2 millimeter till 6 millimeters. After drilling, the first metallization step takes place. For this, the PCBs are brushed and the resin smear on the whole wall is cleaned. This is called desmearing. Next, a thin conductive layer of copper is built up, which is done chemically, and immediately followed by a first galvanic or copper plating process with approximately 10 microns copper, which is depending always on copper requirements of the layout or the customer, of course. So now we have copper on the surface and we have copper on the hole, inside the hole. In a further photo process, the layout of the outer layers is transferred to the PCB. The process chain is nearly similar to the process of the inner layers, except that the resist is now used to partially build up copper. As you remember, in the first photo process, the resist is to protect the copper in the etching process. So now here, all areas outside the layout remain covered by resist, and the PCB layout is defined in the resist. In the plating process, which is followed, the through-hole traces and all copper surfaces are copper plated and to the required thickness. Finally, the copper is protected with a tin layer. This means now the resist is no more the film, the resist is the tin layer. Then we come to another etching process, which is called strip, etch, and strip. The result will be that the outer layers are structures. First, the resist is stripped and removed. Result is a bare copper surface, and the copper of the PCB layout protected with the tin remains. In the etching step, the bare copper is removed, and you can in this step you can see the layout. Before we strip the tin, which remains the copper structures, of course, and the PCB has all electrical function now. After the copper structuring has been completed, the solder mask is applied. Photosensitive resist is applied to the entire surface of the pre-cleaned PCB, dried and exposed with UV light again. Subsequently, the solder joints in the layout are developed so that they are free of solder mask. The only traces are protected, all pads and holes are free of solder mask. For surface coating, the PCBs are first cleaned again and then the desired surface is applied. Typical surface is ENIC, chemical tin, hot air leveling or OSP. The last production step now is, before cleaning, of course, and checking, in consideration to the IPC 600, is the separation of the PCB from the production panel by milling or scoring. At least we will clean the PCBs and run through the last quality gates, which is E-test or the final optical control. So this brings us to the summary. First, we look on the IPC standards of circuit boards and take a closer look to the acceptance and material specification, material properties, and the division into 3 defined classes. Next step is that we learned more about copper foils, prepregs, and laminate or cores in terms of structure and properties. Finally, there was an insight in the production, which means in the most important production steps, of course, for a multi-layer PCB. Of course, you could find more and more production steps, but these are the most important steps. So thank you very much for your attention.